Okay, what we have here is a TG5A Telegraph military telegraph unit, circa 1940s. You can see the key right here, connection terminals, signal adjustments, nice little electrical diagram inside the lid, and then my rigged up battery power source of 3 9-volts set up in a series for close to about 27-28 volts of power. These things ran on anywhere from 22 to 40 depending on the situation. The actual battery that was supposed to be in this is a military BA2. They're extremely hard to come by. They were a type of alkaline dry cell with a 22 volt output, give or take. Not being able to locate one, even if I could locate one of these, it's not very useful because once it's dead, it's dead. The 3 9-volts will work for now. These Duracells are about 200 milliamp hours roughly. I've located some lithium 9-volt batteries that are 600 milliamp hours, and that'll work a lot better. And I may even put 6 batteries, 3 rigged up in series, 3 rigged up in parallel for 1200 milliamp hours at around 28 volts DC in the future, just depending on how long the lithiums last when I test them. It won't be too hard to patch them in. There's plenty of room in there to add 3 more batteries. This one over here is a slightly different unit. This is a TG5B. It's Telegraph Unit 5B. The adjustment for your coil on your signal is one less knob. This one has both a gap and a spring adjust. This one basically has a gap adjust only. To adjust the spring, you have to lift this cover and take a small screwdriver to it to make some tweaks. There's a bell right here. They both have it. And this bell is for use when you don't have the earpiece on. So when you don't have to worry, if it's not a noisy condition, you don't have to worry about the enemy hearing you. What you can do is you simply fire it up and this bell rings every time it goes. You can ignore this cat over here. He is determined to be in this room while I'm working on this, so he really has nothing to do with anything in this project. A quick way to test one of these real quick is terminals L1 and L2 here are for your line that would run between telegraphs. You can either connect L1 to L1 and L2 to L2. That's probably the most secure way of doing it to ensure you have the best signal, because your ground and your supply wire are all connected between the units. The other option would be to go in and do a, you can connect say L2 to L2 and then connect L1 into an earth ground on each side. That allows you to use a lot less wire if you're short on wire, but it also can lead to like dry conditions. You can't get enough power through there to complete the circuit, so you have to use more batteries. You can go up to 48 volts effectively. The only downside of doing 48 volts, in which I'm going to add a little circuit in to protect against that, is if both keys on both units are pressed at the same time, it would create over a 90 volt charge and could damage the circuitry if it happened for more than a brief second. So the idea is to come in there and do a I could put in an MOV, a metal oxide varistor, or some clamping diodes to lock it so it doesn't get any higher than say 60 volts total ever, and that would prevent that problem. If you don't have your units, you want to test the unit to make sure it works right, you simply short L1 terminal over to L2. You can use a knife if you want. I'm just going to use this little coil of 2 wires. See if I got this right. I might have to switch wires here. There you go. And then what happens is with the unit unplugged, of course you have to adjust the key for your particular feel, and I'm just not very good at Morse code. There we go. In conditions where you wouldn't want the enemy to hear you banging out a telegraph without ringing noise, then you can hook in this headset. You can also use this as a side tone generator on a radio circuit. You can make an adapter out of this kind of plug and a different one. I had to plug this directly in to say a switchboard on field telephones or into a shortwave radio and create a side tone and knock out Morse code that way. But this could be strapped to a person's head. Etc. Okay. Now I'm going to show you what happens when you secure this to a tripod real quick. Now I'll show you what happens when you connect the two units together. This is just a very thin set of wires I'm using here. You wouldn't normally use anything like this, but running at such a short distance. I did some ammeter readings, and you're using about, every time you push the key down, you're using approximately 40 milliamps of electricity to run the circuit. And depending on how long your run is, you would adjust these dials or this dial for best signal in both directions. And that's where the old Q codes come in radio work, because originally it came up for telegraphs, because nobody wants to type out the phrase, how is my signal, you know, especially in the battlefield conditions, to the other person. So there's a Q code for that. It consists of 3 letters, a Q, S, or Q, whatever. I don't honestly remember where they are. I'd have to look them up. But you would contact the other station. You would knock out the 3 letters like that, and they would know that's a question. And they're saying, oh, well, you know, he would respond with QS, so good, better, low, weak. Or if you don't get any response at all, there's either not a manned telegraph unit for some reason, or they just didn't get your signal. But yeah, you could adjust it depending on the length of wire. Under good conditions, if you're using, say, WD1A wire, which is a standard field telephone wire setup, there's a lighter grade one that's called a salt wire because it weighs a lot less. But usually they use WD1A. They used to use WD100, but I can't even find specs on that particular type of wire at this point to see what the difference is. But WD1A has about 48 ohms of resistance, DC resistance, for every 1,000 feet of run. So a 50-mile run is something like 4 kilo ohms of resistance on both wires. And you could always simulate that by putting a 4 kilo ohm, 5 kilo ohm resistor, 2 of them on each of these terminals coming up to the wires. We could test to see that if everything is working right over such a long run, because you should be able to get 40 to 50 miles out of a standard battery set at just 22 volts with that kind of resistance. Let me show you right now. This is all hooked up. You've got your negative 22 volt here and your positive common connection. A little different than modern equipment, but not a big deal. And then there's a negative 3 volt connection. This would allow someone to run an external power source to this thing very quickly. This allows you to string multiple batteries together and tap them into the terminals and so forth. They even come with a little tool here. This is a tool for cleaning and checking the gap on relays. So we'll test it out and see what happens. And this one, of course, is ringing. Let me test this one. Both of them will ring when they're not plugged, when the headphones are not plugged in, and that's so that you can hear what you're doing. And so forth. Pretty nifty little devices. You can find them on eBay fairly inexpensively sometimes. I mean, unless somebody's let the batteries, you know, just fail inside and corrode out the inside, they should be in good working condition. All I did to get this operating, I was afraid the capacitors, there's 2 capacitors in each one of these, and it's behind the bell in the back. It's like one of those block capacitors that was made up, has 4 connections on it, and about 8 different wires. And it's basically 2 0.25 microfarad capacitors. I haven't even looked at them yet, and they don't say in the spec sheet what type they are. I suspect they probably have a rating around 50 or 60 volts. maximum, and they are probably made out of paper or possibly some kind of electrolyte. But they appear to be still working just fine, so I'm not going to mess with them. I did buy some 0.22 microfarad mylar film 300 volt capacitors because they're tiny, they're pretty high tech, and they'll last forever in these devices. If I have to, I'll just take the block off the back and solder them in and reconnect everything and try to make it look as original as possible, except to be running on modern capacitors. Trying to think of anything else on here. It's interesting. Other than that, my other idea is that this does not work out to be enough milliamp hours for long-term usage. What I'm going to do is these lithium batteries I got a hold of, they were 9 volt, 600 milliamp hours. I'll go ahead and connect 6 of them up in each of these units, which all I did was solder the connections together and heat shrink tubing them and add in some heavier hookup wire. And that way we can simply run it at about 1200 milliamp hour for, around 27 volts, 28 volts, depending. And what I'll do is that when they need to be recharged, I have to disconnect all the batteries from the connectors up here and just put them in the rechargers that are part of the deal that I bought them on. What I may do is construct there's some circuit boards from China you can buy that they're set up as universal battery chargers. You can set up your initial voltage and your initial current, and then your final voltage and your final current trigger, and just rig them up to charge those lithiums at whatever voltage I need to calculate in for it, and however much current to charge all 3 or all 6 at one time. I'm thinking I'll be fine with just 9 volts in each unit. I will be doing a test soon using these with some resistors in line. I might go pick up the resistors I need tomorrow and hook up to simulate we're running 50 miles of wire between these two units or not. And that's under good conditions. If the wire, even though it's got a 10 or 100 mega ohm resistance on the jacket, is wet, if it's like going through a lake or mud puddles, it will actually still leach some power out of the circuit and create a little bit of a problem. That's why in general, even though if the wire is in perfect condition, you weren't supposed to run it unless there was another option through lakes or rivers or ponds or anything like that, because being wet, you will lose a little bit of circuitry current through there regardless. Dry conditions, 2 wires between units with the original BA22 battery, the BA2 battery, which is 22 volts. You can get hours and hours and hours of solid use or more out of it at 50 miles. More than that, you have to put a relay in between of some kind, which really wouldn't be too hard to build a relay to complete the circuit and have a big battery in there to act as a signal booster. Could probably use a good old 1930s, 1940s civilian telegraph relay to do it with. And that's about it. Hope you all enjoy. And once again, this cat just appears to want to stay here and be in the picture.